Hey y'all, it's me, Miss B. Today we're talking about exponent rules and performing operations on exponents, and we're going to break that into a couple of days. So this is day one. First, we need to learn our basic exponent rules. So the first one is when we have a negative exponent. We have a negative exponent, the negative numerator is going to move to the denominator. So here you can see that b to the negative 2 is negative. So what's going to happen is it's going to move to the denominator to make it positive. So what we end up with is the a and the c stay, but the b comes to the bottom and then is made positive. Okay, so I'd make a note that it becomes positive when it moves. Same thing when it moves up. If you have a negative in the denominator, it's going to move to the top to become positive. So my a and my b squared are going to stay, but my c to the negative 3 becomes c to the third in the top. Easy as that. All right, here's our next exponent move when we have 0 as an exponent. Anything to the 0 is equal to 1. So 5 to the 0 is 1. 19,264 to the 0 is 1. And then this one we have to be a little careful. So xyz to the 0 is 1. But 3 times 1 is 3. So we just have to be a little bit careful of that. Okay, so I would make a note that xyz to 0 is equal to 1. Okay, so go ahead and try these on your own. All right, so what you would have done was rewrite this over 1. And so you have 9 to the negative 2 over 1 is 9 over, I'm sorry, not 9 over 1. So then this is technically 1 times 9. So you have 1 over 9 squared. So that moves to the denominator, making that positive. And then when you simplify, you get 1 over 81. This next one here, we've got negative 3.6 to 0. It's 1. Okay, so this next one here, we want to rewrite this before we do anything else. So we've got that negative there. I'm going to go ahead and put this over 1. So then when I rewrite, I have 3s to the third over t squared. So that squared becomes positive when we move it. Then we can plug in our values for s and t. So we have 3 times 2 to the third over negative 3 squared. Simplify even further using PEMDAS. We don't have any parentheses. Exponents, 2 to the third is 8. Negative 3 squared is 9. All right, and then we simplify. 3 times 8 is well, let's simplify first. That would cancel with this. This would become a 3, and then we get 8 over 3 is our answer. All right, now I want you to try these next few on your own. 4 to the negative 3, you get 1 over 4 to the third, which is 1 over 64. Don't be afraid to use your calculator. Negative 5 to the 0 is 1. 3 to the negative 2 is same thing as 1 over 3 squared, or 1/9. And then negative 4 squared, that's the same thing as 1 over negative 4 squared. This negative has to stay. This negative becomes a positive 2 and we move it. So then we get 1 over 16. let's look at this next set of problems here. Okay, so 5a to the third b squared. That -2 is a no-go. What we'll do is we'll take that 5a to the third, keep it the same, but that b squared has to move to the bottom. This next one here, 4c to the -3 over b, we'll put that over 1. That -3 is a no-go, so we will move it to the denominator. So we have 4, b stays, and then c to the third moves. This next one here, this is 1 times n to the -5. That -5 is not good, so what we're going to do is we'll move it to the denominator next to the n, and then in the numerator, I'm still left with a 1. All right, go ahead and try these next two, or last two, on your own. For this one, you should move that 5 to the top because it was negative, and so you get x to the 5th. And then this one over here, don't like that negative, got to move it to the top, so we get 2a to the third. Let's save this problem and go on to multiplying exponents. Okay, so what's each expression written only using one base? So I'm going to rewrite 3 to the 4th times 3 to the 2nd as 3 times 3 times 3 times 3. That's 3 to the 4th. And then 3 squared is 3 times 3. So when I multiply all these together, I get 3 to the 6th because I have 1, 2, 3, 4, 5, 6 3s. Let's look at this next one, 2 to the 5th and 2 to the 3rd. So I have 5 2's. So I'm going to do 1, 2, 3, 4, 5. And then I have 3 here. So I'll do times 1, 2, 3. So now I have in total 8. So I get 2 to the 8th for that one. All right, we don't want to add our exponents up like that every single time, so here is our note. This only works with exponents that have the same base, and it's called the product of powers. Now, when multiplying numbers with the same base, we are going to add those exponents. So here I have m and n, and to multiply them together, we get m plus n. Okay, so let's do this example here. So I have 12 as my base and 14 and 3. When I add 14 and 3 together, I get 12 to the 14 plus 3, which is 12 to the 17. So that right there is our final answer. I am in a really bad habit sometimes of making my exponents the same size as my numbers. So whatever you got to do, make sure it's obvious that the exponents are not the numbers. All right, go ahead. Let's do another one together. Let's do this one here. Okay, so our base is -5 and our exponents are -2 and 7. So I'm going to do -5 to the -2 plus 7, which gives me -5 to the 5th. And we're done. All right, go ahead and try these next few on your own. Okay, so for this one, we have 8 to the 3 plus 6, because we add those exponents together, and we get 8 to the 9th. This one here, we've got 0.5 to the -3 plus -8, which is -3 minus 8, which is 0.5 to the 11th, but we don't like negative exponents, so we'll write it as 1 over 0.5 to the 11th. You have to remember those special exponent rules. All right, and then this one, we do 9, negative 3, plus 2, plus 6. We can just do all of that at once, and so we get 9 to the 5th for that one. All right, we're actually just do a couple of these together. Do these two. Ooh, okay. Gonna do these two together. So what I'm gonna do is when I do these problems, I multiply my two coefficients together first, and then I multiply my variables together. So I'm gonna do 4 times 9, that's gonna give me 36. And then when I multiply those exponents together, z to the 5th and z to the 12th, I get z to the 5 minus 12. So that ends up being 36z to the negative 7, but we don't like that negative exponent, so it becomes 36 over z to the 7th. Super fancy. Okay, let's look at this x one here. Oop. All right, you'll notice that here and here we have the same base, but this one is different. Let me actually write it above here. We've got a different base, so we can't combine them. So I'm just going to multiply my exponents together, or I'm sorry, my coefficients together. So I'm going to do 2 times 9 times 3. And then I'll also do a times a squared times b to the 4th. It's a to the 1st there. So when I multiply all these together, I get 54, because 9 times 6 is 54. And then these two together is a to the 3rd. And then that b to the 4th, it's all by itself, so we'll just leave it as b to the 4th. We just read it in alphabetical order. We've got a big old rainbow here, so I'm just going to rewrite it as a 54, a to the 3rd, b to the 4th in one color. All right, and then I'm going to leave those for you to do on your own.